Welcome back once again, and like I said, the first resource we're going to be exploring is like the Cairo book, and we're going to be looking. It's going to like expose us to like everything you probably need to learn about the Cairo programming language. This is like one of like the most detailed resources out there you'd find on Cairo, and yeah, so we're going to be walking through it: introduction to Cairo, smart contracts in Cairo, advanced darknet contracts, and so on and so forth. Yeah, so like I said, the current book was built by the community led by Fricoben and Anytrat, and of course, special thanks to like Starkware and Only Dust for like and I think Voyager for sponsoring like the creation of this book. All right, so we're going to be going into like the forward section. So the forward section basically talks about the background of Cairo. So Cairo was basically introduced in 2020 by the Starkware team, and it was like the first ever Turing complete programming language with support for like verifiable computations. Now Cairo is like a major breakthrough, right? Because it's a bit or a lot way different from like your average programming language. I mean, Cairo gave like I said, created like the first support for like verifiable computations, just to really understand how amazing this is, right? So in the past, before like the invention of Cairo, to basically create preview programs, you most times needed to represent your programs in like using like a set of polynomials over like a finite field, right? Which is a process we popularly known as arithmetization. Examples are probably like you probably heard about the rank one constraint system, which is very popular in SECOM and so on, and also the what's it called? Algebraic intermediate representation. That's the A, which is what Cairo uses, right? And just a fun fact, just in case you don't know, like the name Cairo is kind of like a short form for CPU air. You don't ask me where the O comes from. To be honest, I really don't know. You can probably like ask the engineers from Starkware, right? Yeah, and it's kind of like a weird name, and yeah, you're not the only one who thinks that. So yeah, so when Cairo was introduced, right, in 2020, it was like more like a full-blown assembly language. But it's with time it began to like become like way more expressive, right? So Cairo 0.x for people who are in the ecosystem as at 2021, 2022, right, was quite like a pain in the ass. It was a bit difficult to like get through for normal people like you and I, right? So it was not really an easy leg, right? So but thanks to like Cairo 1 came in and it simplified like the whole ecosystem. It was a lot more Rust-like, which meant that developers or Rust developers like had an edge and could easily like get through, since like a lot of it concepts were like gotten from like existing Rust concepts. And thanks to like the Cairo virtual machine being powered by like basically Rust VM, it means that the execution of like Cairo programs is like blazingly fast, which means you can basically build extensive test suites without compromising on like performance. Now Cairo is like I said, Cairo is like an amazing programming language. In the next section, which is like an introduction, we're going to be looking at what the Cairo programming language is. I already gave an intro into that though, and basically why you should learn it. And of course, acknowledgements, right? So just like I said initially when we started, this book would not have been possible without like the help of the community. So a lot of amazing developers within the community came together to like contribute to this book. And once again, a big shout out to like the leads, who, like I said, Anytrat and Fricoben, very amazing guys. They made this possible. So in the next chapter, let's just dive into like an introduction and talk about why you should learn Cairo and Starknet, why you should spend your time, why you should dedicate your time to it. So yeah, so I explain what Cairo is. So Cairo is a programming language, right, designed for a virtual CPU of the same name. So it's like the first Turing complete like language for verifiable computation. So with the invention of Cairo 1, so Sierra, an intermediate representation, was introduced, right? So those who were in the ecosystem as at 2022, right, you know that there was a there was a very popular problem, which was the fact that field programs proofs could not be generated for field programs, right? And this opened room to like DDoS attacks, right? Because it meant that field programs could not be proven, which means probably gas fees could not be charged for them. So, but with the introduction of Sierra, it makes it possible for you to generate proofs for like field computations. So previously it was Cairo program to Chasm, which is short for the Cairo assembly, but right now you have Sierra in the middle, so it's more like Cairo to Sierra to Chasm. If you need more information on how this works, you can check out like I think the StackNet book, or there should be some resources linked down here. There's this amazing article from Nethermind you could probably check out. Yeah, so what can you do with Cairo, right? What can you do with it? Why should you learn it? So just like I explained earlier, Cairo allows you basically to compute trustworthy values on untrusted machines. So the basic idea of zero knowledge proofs, right, is the ability to like prove to people, prove to individuals that you know something, right, without revealing that which you know. So one of like the big advantages of Cairo, like I said, right, is that you can write programs and basically generate proofs for them. So it means that we could actually like compute trustworthy values on untrusted machines and basically verify it on other smaller computers. So one of like the biggest basically like should I say implementation of this, right, is StackNet. So StackNet is like a layer 2 built on top of Ethereum. So the idea of StackNet basically is to like scale Ethereum. StackNet takes advantage of like zero knowledge proof to do this. So with StackNet, it's more or less like rather than everyone probably like execute transactions on Ethereum, right? It's being a rule of basically what it does is a lot of all the transactions what's it called, executed off-chain, right, on StackNet, and these transactions are basically passed to the prover, who generates a proof that all these transactions were like done with integrity, right? And this proof basically is sent to the verifier smart contract on Ethereum, which verifies that the proof generated is correct. So the basic properties of zero knowledge proof: completeness, which means that if the proof generated is correct, it simply means that you should be able to prove like without doubt, right, that this is correct. Soundness, if it's not correct, then the prover should not be able to convince the verifier that it is correct, right? And zero knowledge proof. So at the end of it all, the verifier probably has no knowledge of like the whole transaction, the whole computation. Yeah, so that's just basically the idea behind how StackNet scales Ethereum. All the transactions, everything you do on StackNet, right, is computed off chain, passed through the prover generates proof of these transactions. Basically this proof is sent to the L1 on Ethereum. So this approach allows for increased throughput, basically scalability and reduced transaction cost, while at the same time preserving Ethereum decentralization and security. So what are basically the differences, right, between the Cairo programming languages and other programming languages out there? So Cairo is like is quite different in a lot of ways. So one of them, right, is that basically, like, let's just return it. So when executed by the prover, right, Cairo is very much similar to any other language. Because Cairo is virtualized, the operations were not specifically designed for maximum efficiency. This can lead to some performance overhead, but it is not the most relevant part to optimize. Okay, but let's take a look at the second difference, which is of more importance to me. So yeah, it says when the generated proof is verified by a verifier, it is a bit different. This has to be as cheap as possible, since it could potentially be verified on many very small machines. So yeah, while it might require a little bit of computation overhead to like generate a proof, the verification is like super easy and can be done on like very small machines, right, which that doesn't have like a lot of computation power. And furthermore, like it's the concept of non-determinism. So basically it means that you can use a different algorithm to for the verification of the computation. So currently writing non-deterministic code is not really supported for developers on StackNet, right? But following the tweets by Shah, which you could probably see somewhere later, it's something that we might probably look forward to. So another aspect, right, in which it's very much different is the memory model. So in Cairo, memory accesses are immutable, which means that once you write a value to the memory, it cannot really be changed. But with Cairo 1, there's basically Cairo 1 provides a sort of abstraction that helps developers work with these constraints. So it's a concept of mutability, but does not really exactly fully simulate the mutability you have with other programming languages. So we're going to be looking into this in further chapters as we go. But so for references, if you're looking to read more how the Cairo CPU architecture works, there's this amazing Cairo white paper you can check out. There's also this amazing article from the Nethermind team, which goes into the underhood of Cairo 1.0, exploring Sierra and other stuff. And the state of non-determinism, you could check out this tweet from Shahab Apimi. This was a lot of reading. From the next video, we're going to be getting our hands dirty. We're going to be going into installation, installing Scab and other stuff we're going to be using during the course of these tutorials. So if you learned something new, please share with someone else, and I'll see you in the next video. Thank you. And also definitely looking forward to feedbacks. Please leave your feedbacks in the comments below, and you could always reach out to me on Twitter, 0xDarlington, and they're very much open to your feedbacks and comments. Thank you. Until in the next video.